Hello guys, I am Nidhi Bagalwadi, your science teacher. So in the last class, we solved certain problems related to the focal length of the mirror. Today we are going to solve a problem regarding the focal length of a lens and regarding two more problems which may come for 2 marks. Okay. So for this, you should be known that the concepts of convex lens and concave lens, and you should know that when the virtual image or the real images will be formed, when the image will be diminished or magnified. For all this you should be perfect in case of the ray diagrams as well as the concepts when you will get magnified or the diminished. So before solving any problem out from the question bank or from any reference books, please make sure to be perfect in these theoretical concepts. Then only you can solve the problem, because for in every question they will be asking the nature of the image, which will be for 2 marks or 1.5 marks. Okay, right. So let me go to the one more problem, that is a 5 centimeter tall object is placed perpendicular. 5 centimeter means height of an object is 5 centimeter perpendicular. So let us draw a rough diagram over here. This is a principal axis and here a 5 centimeter object is placed. Perpendicular means 90 degree to the principal axis, and this is a concave lens. They took concave lens. Then the focal length the focal length means what? The optic center to the image, the focal length. So image will be formed here, right? So the focal length will be of 20 centimeter, they said. Then the object distance they said as 30 centimeter. Okay. Then we have to find the image distance as well as we have to find the image where the image will be formed. Then nature of the image also we should find. Now let us take a height of an object which we consider as HO. H is height, O that is to the subscript. We should write down it is the object. HO is equal to 5 centimeter, U minus 30 centimeter. So why I took minus 30 centimeter? We know that in convex lens an object distance should be considered as minus 30 because it will be against the direction of the incident ray. If this is the direction of incident ray, the object distance is away from the direction of incident ray. So the object distance should be considered as negative in case of convex lens. Okay. Now, so I took it as minus 30 centimeter. Next we have focal length 20 centimeter. Here we have to find the image distance. So this is a lens formula, 1 by V minus 1 by U is equal to 1 by F. So I want 1 by V, that is I want image distance. So mathematically we have to rearrange the equation. Then after that when we solve 1 by 20 plus of minus 1 by 30. Then when we solve the LCM will be 60. Then I got V, 1 by V as 1 by 60. So I want only V. So what we have to do? We have to reciprocate. So V will be 60 centimeter. So we got image distance as 60 centimeter. So when you take object distance and image distance is more. So when it is formed away from the lens, then how the nature will be? So let us see. Now they also asked regarding the height of the image. So we know that the height of the image is given by magnification. So magnification is equal to the ratio of height of the image to the height of the object. It can also be given as the image distance to the object distance. So height of the object I solved. So when we consider this, when we cancel this, when you solve for the height of image, when you equate both, so height of image will be V by U into height of the object. This is the equation, right? Then after that substitute the values. V is equal to 60 centimeter, what we got? Okay, the image distance. Then we got U, it is already given as minus 30 centimeter, that is object distance, into 5. 5 is height of the object, it is also given. So when you solve, we will get it around minus 10 centimeter. So height of the image is minus 10 centimeter. Then height of the object is 5 centimeter. After that, so image will be real. It is real. As it is minus, it will be inverted. It is in real because it is of convex lens. right? Then it is inverted because we got minus 10 centimeter and magnified. It is away from the mirror and it is magnified. Means why? Because here the image distance we got 60 centimeter, here it is minus 30. So minus 30, 60 centimeter we think it is away. No, it is here only, this side only, 60 centimeter. So that is why we will get the magnified image. So this is regarding the problem. So for this I said you should be perfect in the concepts of concave and convex lenses, that is especially the nature of images. Then only you can write the nature of image. For this you will be having at least 1 or 2 marks. Then the 2 marks questions will be like this. Find the focal length. I wrote in symbolical form because it will reduce that is my board space. Okay. It will be in a statement actually. Find the focal length of a lens if its radius of curvature is 32 centimeter. So we know that what all we are considering the lenses and the mirrors in this chapter, we should consider the aperture is small. So when the aperture or the length of a whole mirror or the lens is small, the formula will be always the focal length will be half of the radius of curvature. So here 32 centimeter is a radius of curvature divided by 2. So it is 16 centimeter. So focal length is given by half of the radius of curvature. We got the value 16 centimeter. Next, find focal length if P. P refers to the power of the lens is equal to minus 2 dioptry. D means what? Dioptry, the SI unit of the power. So we know that power is given by reciprocal of F. Now we want minus 2, it is equal to 1 by F. So when we take F here, it will become minus 1 by 2. So the focal length will be minus 1 by 2 centimeter. Sorry, it will be always in meter. When focal length is expressed in meter, then only power can be explained. Okay, so minus 2 meter will be the focal length. So for, like this you will get the problems of 1 marks or 2 marks for short answer and very short answer. So these are the problems in the light chapter. Solve more problems from the textbook as well as from the reference books. So in the revision crash course, we will solve more problems. We will practice more problems. Until that, be perfect with the concepts of convex lens and concave lens, especially the nature of the images. Then only you can solve the problem of this topic. Here, we completed the chapter light completely. Today, we will wind up the chapter light. So in the next sessions, we will expect a lot more from the physics concepts, a lot more to learn, a lot more to enjoy. So I will meet you in the next session. Until that, have a nice day.